Once again, wind is set in motion by uneven heating of the ground causing pressure differences. So if you look down here at this image, remember everything starts with the energy from the sun. The sun does not heat the air. The air gets heat from the ground. So the sun heats the ground. Then the air moves along the ground and it gets heated through conduction. So remember, conduction, convection, and radiation are three extremely important terms to remember as you continue to learn about weather. So when we talk about wind, we have to talk about two categories of wind. We have global winds and we have local winds. Global winds are winds that travel for thousands of miles in steady patterns. They last for weeks, and they are generated from uneven surface heating. Now, the next part of the process is what complicates things, because if it was simply the fact that the earth was heated unevenly and that set air in motion, what we would see are all of these winds traveling directly from north to south. But it doesn't work that way because the earth rotates, it spins on its axis, and that affects the path of these global winds. We call this influence, this force, the Coriolis effect. And if you look at the image here, you'll see that wind, that if it was generated here at the North Pole, as it flows towards the equator, it's actually going to curve. All right, you see that curve. And that is because of the spinning of the earth. Hurricanes are Coriolis mechanisms, and a lot of the different wind spirals and things like that that we're going to see, that we're going to be talking about, are generated because of this Coriolis effect. Before we talk about the actual wind belts, we're going to focus on the calm regions that separate them. All right, so there are two what we call calm regions of the planet. The doldrums is the first. Now, if you look here at this image, right along the equator, you see to the south doldrums, to the north doldrums. So the doldrums here are low pressure zones that straddle the equator. Here we see rising warm air creating clouds, heavy rain, and really fueling our tropical storms. If you notice, the area right here around the equator, this is where hurricanes, cyclones begin, and it's where they do their most damage. So the doldrums are stormy, unstable areas. The next calm region is the horse latitudes. Now, the horse latitudes, if you look here at 30 degrees north latitude, and then down here at 30 degrees south latitude, those are the horse latitudes. And they are distinguished because they're high pressure zones where we see this sinking cool air and extremely clear, calm, and dry conditions. Look, if you have a sailboat, you don't want to go sailing in the horse latitudes. Ain't no wind, all right? You're not going to get very far, so you better have a motor on your boat, all right? So these are the two calm regions. And remember, the doldrums straddle the equator, the horse latitudes at 30 degrees north and 30 degrees south. You can see in between our calm areas here all of these different colored arrows, and those are our global wind belts. All right, you see that they're curved. All right, that's the Coriolis effect. So the trade winds are these red arrows here, and they blow from the east to the west, from the horse latitudes down to the equator. They're strong and steady, and they sort of die out once they hit the equator. If you were in Hawaii, you would feel the effects of the trade winds pretty much constantly. They don't stop. For our purposes here, the westerlies are the most important of the global wind belts. Why? If you look at these purple arrows here, moving from west to east, from the horse latitudes to the poles, the horse latitudes, or I'm sorry, the westerlies are what are responsible for bringing us our weather here in Pennsylvania. The easterlies, you can see, are polar wind belts. They're the yellow areas here on this particular image. And they blow from the east to the west, from the poles to the middle latitudes, and they will also bring some stormy conditions. So look, the positions of these calm regions and these global wind belts, they result in some sort of geographic features that, look, rainforests, they are not on this planet where they are spontaneously for no reason. If you look here, this slide shows our tropical rainforests of the world, all right? And notice, here's the equator, okay? So the doldrums on either side of the equator, with their stormy, rainy conditions, provide enough moisture for these tropical rainforests. So it's no surprise that the tropical rainforests of the world are in the doldrum areas here, straddling the equator. With deserts, it's no different. There are some mountain ranges like the Andes Mountains here in western South America. We have the Himalayas here in Asia that will, have some effects on these deserts. But if you look, the horse latitudes at 30 degrees north, 30 degrees south, see where these deserts are, okay? They're there for a reason. So the calm regions and the wind belts contribute to climate quite a bit. It's important to remember that. Another thing that is responsible for our weather and for bringing weather is the jet stream. Now, the jet stream flows near the top of the troposphere. And what the jet streams are like these tubes or really strong currents of air that all flow from west to east. They can hit speeds of up to 200 miles per hour. And if you look here in this image, you see this polar jet stream here, how it dips, it dives, it rises. That's because there are certain air masses here that are blocking the path. So the jet stream will flow around and it will flow through, it will flow around and flow in between these different air masses. And this polar jet in the northern hemisphere here, that's the important one for our weather in western Pennsylvania. What we'll notice as we continue to study weather is this jet stream, sometimes it will rise and it will it'll pull air from the Gulf of Mexico, warm, moist air, and it'll pull it up towards our direction. At other times, if the jet stream dips below where we are, we'll get this cool, dry air coming from Canada. And when these air masses meet, these cool, dry Canadian air masses and these warm, moist Gulf of Mexico air masses, that's when we get our severe storms. All right, so we need to pay attention to the jet stream, particularly the polar jet here in the northern hemisphere. So that's it for global winds. How about these local winds? If you step out on your porch, for the most part, you're going to be feeling a local wind. We have these divided into sea and land breezes and mountain and valley breezes. And, most of us have been to the beach. If you haven't, or, if you haven't tried this, next time you go to the beach, try this. During the day, just stand on the beach and face the ocean. What you're going to notice is, during the day, you're going to get a stiff breeze that hits you right in the face. That's because land heats up and cools down faster than water does. So during the day, what happens is you get this dense ocean air moving towards low pressure that is created over the land. All right, so the wind is going to essentially hit you in the face. Now, if you go back out at night and you try this same experiment, you just stare out at sea, you're going to notice that the wind is going to be hitting you in your back. That's because at night, this process reverses. You get the low pressure forming over the ocean, and you get the air moving from land towards the ocean at night. And that's what we call a land breeze. So you get sea breezes during the day, land breezes at night. In the mountains, it's the slopes that heat up and cool down faster than the valleys. So during the day, you're going to get these valley breezes that are essentially flowing up towards the low pressure. Then at night, that process will reverse, and you'll feel the breezes flowing down from the peaks of the mountains into the valleys. So that's sea and land breezes. The last thing that I want to discuss here are monsoons, because here in PA, when we say monsoon, we think of heavy rain. Oh, it's a monsoon out there. But that's really not what monsoons are. Monsoons are prevailing wind patterns, all right? And they're really important in South and Southeast Asia, countries like India, where billions of people rely on these seasonal wind patterns. So what we have is, in the fall, what we have is the wind pattern blowing from the sea in towards the land, all right? And so that is India's wet season. All that moisture from the ocean is going to be coming onto land and being dropped in the form of precipitation, heavy rains. On the other hand, if you look here in April, this is going to be the dry season. You see the wind pattern has reversed, and the winds are blowing from the land out towards the sea. So that's going to give the dry season in India. Recently, these reliable monsoons have become unreliable. All right, climate change is wrecking these patterns. India has had severe drought. They've had record flooding. They've had temperatures of 120 degrees Fahrenheit in some areas. So, we need to understand that these monsoons are extremely important to billions of people, and that man-made climate change right now is wrecking this system. So, as we learn more about weather in the coming videos, remember the importance of monsoons, jet streams, global winds, calm regions, and we'll add this to our learning in the next video. Take care.